Welcome to this meeting from Poznań to another local development forum, this time devoted to the activities undertaken by cities with regard to climate change, climate resistance, something that applies to every city in the world and Europe. In 2026, we focus on presenting practical experiences from Swiss and Polish cities, and our local development forum is organized by the councillors of the Association of the Polish Cities in the predefined component project in the program of support of Polish cities in effective use of the Polish-Swiss collaboration program with the framework of the Polish-Swiss City Development Program, co-financed by the Swiss funds. Our meeting is traditionally translated into Polish Sign Language. We have the translators, interpreters of the Polish Sign Language with us, Ms. Joanna Ciesielska and Ms. Magda Szromowa. All the time, especially for those who have just joined us or who are with us for the first time, we provide technical support. If there is any need, any problem, please contact our colleagues. You have their data here so that you can solve any problems that might appear. A very important area, just before this seminar, we've been speaking that this week on Monday, there was the World Marshland Day, which was celebrated in many cities of the world. So our topic places itself perfectly well in this broader environmental issue. So as you said, these climate change problems, rainwater management, water management is a big challenge, but at the same time, it's a broader topic related with heat islands. So generally speaking, this is the area related to adapting to climate change and minimizing the influence of climate change on the cities. Today we'll start with the sponge city concept, and we'll see St. Gallen and Bydgoszcz cities with this regard, but then we're going to have a broader approach. How can cities be designed with biodiversity in focus? And we'll finish by discussing with one tool that is helpful in managing cities that is used in Switzerland, that is Heat Toolbox. This is a sort of a guide how to prepare the city for climate change, how to make it more resilient. This was prepared for the city of Lucerne, but now it's used by many municipalities in Switzerland and I believe also in Poland. So a lot of practical solutions for middle-sized cities. Ladies and gentlemen, welcome everyone to our chat. Throughout the whole meeting, the seminar, you are free to ask questions, to participate in discussion. And right now, let me pass the floor to introduce us to the problem by Nina Dausz, deputy head of the project in our Swiss partner of the support instrument, and Mr. Andrzej Porawski, director of the office of the Association of Polish Cities.
All right, so also from my side, good morning, everybody, and welcome to today's seminar. Since Tomasz and Lukasz also introduced us or the content of the seminar quite very well, so I'm just trying to give some further inputs. So my name is Nina Dausz, and I'm representing our consortium ENCO-ÖBA-Plan today. So we are mandated as the support measure partner, and one of our main tasks is to facilitate experience exchange between US representatives of Polish towns and Swiss experts in close cooperation with APC. So as already mentioned, today we are addressing the very pressing topic of climate change adaptation, which is becoming a key issue everywhere. So not only in Poland and in Switzerland, but in every country across the world. So in Switzerland, these impacts are already appearing in a very intense manner, and they are also very noticeable for all residents. In Switzerland, we also have the mountain regions, and they are especially vulnerable. So glacier melt, for example, is accelerating, and therefore the risks of landslides, rockfalls, and erosion are increasing. I don't know if it was reported in the Polish media, but in the municipality of Brienz, for example, there was a massive rock slide which stopped just shortly before the village. So this is just one example, but you can see that in Switzerland, people are really facing a very different manners of climate change impacts. So, since we are focusing today on heat and heavy water rainfalls, I'd also like to express that Switzerland is warming very quickly, so about twice as fast as the global average. Um, you can see that cities are increasingly exposed to heat stress, but also to heavy rainfall. This is making climate adaptation an urgent urban issue. Um, these effects do not only reduce the well-being of citizens and the quality of life, but it is also a serious health risk. So especially for older people and other vulnerable groups. Um, yeah, this creates a very strong need to adapt urban spaces. And Switzerland has been very active in this field and has a lot to offer when it comes to climate adaptation concepts and measures. So we are very pleased that we were able to mobilize three highly qualified Swiss speakers who will share their expertise today and offer a Swiss perspective alongside to the Polish perspective that will be presented by Mr. Żywiecki. Tomasz and Lukasz already introduced our speakers, so we will have Tomasz Piątek from the city of St. Gallen, who will also talk about our focus on the sponge city concept. Then Alexander Sauthoff will speak on urban planning for biodiversity, but also for greener and resilient cities in total. And Johanna von Toppenburg will address the heat toolbox and show some examples of the canton of Lucerne. So I'd like to thank all our speakers, and I'm wishing you an inspiring session. Thank you.
I prosimy dyrektora Biura Związku Miast Polskich, pana Andrzeja Porowskiego.
And now I'd like to ask Mr. Andrzej Porowski, Director of the Office of the Association of Polish Cities. Welcome, everyone, to yet another seminar co-organized with our Swiss partners under the framework of the project that we'll implement in the forthcoming years, the City Development Program. I'd like to say that this field that we focus on today is of particular importance for practical reasons that we feel more and more. And nonetheless, it is still politically tainted somehow. A few words about it, because I'm shocked when an important politician, globally important politician, says that climate change is a fraud. And also when he's supported by quite a few Polish politicians who want to prove with the harsh winter that we have after quite a few years as the ultimate proof that there is no climate change, since we can still have a cold winter. Even such a sad experience of the last days that I quote here, that we've all gone through and we've been affected by, well, seems that it does not dampen the mood of these pseudo-politicians. Speaking of practice, in the last 20 years or so, we've had 2 millennial scale floods and 1 century scale flood on the Oder River. So in 20-something years, we had 3 great floods, to speak plainly. Great intensivity of local floodings related to severe precipitations, especially difficult in the cities. Against this backdrop, the activities undertaken by Bydgoszcz, which are more and more recognized in Poland, are a reason for great respect. Bydgoszcz is a city that treats environmental issues very strictly, very sincerely for years. I don't know if you remember, in the 90s, Bydgoszcz was the first Polish city to receive from, I don't remember which international organization, the title of the Garden City. At that time, in early 90s, even Bydgoszcz was surprised to receive such a title. And it was granted to them, it was awarded to them only because of certain fragments of the city. I'm speaking of the Myślęcinek area. But in the meantime, Bydgoszcz treated that title not just as a reason for prestige, but also as a challenge. And today we can say honestly that this greenery development planning in the city has become exemplary to other cities, and this Garden City title is more and more true. Well, I'll give the floor later on to the representatives of the city themselves, and I'm sure they will do it better than I. I'd like to thank the Swiss side for sharing their experience with us, because these different geographical conditions, supposedly unlike ours, as we have just heard, make Switzerland that the intensity of these climatic changes is even stronger than anywhere else. So I'm convinced that the Swiss experience in this field will be of particular usefulness for us. I'd like to wish everyone a lot of impulse for action, because the exchange of experience is always the greatest and the most important impulse for work. I wish you all a great meeting. Thank you very much for introducing us to this meeting. And before we start the first presentation, let me just share, for those who have just joined us, two pieces of information. Our meeting is translated simultaneously into English and Polish, so I'd like to remind you that you can choose the right audio channel. In the lower bottom bar of Zoom, you have a globe icon. You can click it and choose English or Polish or the original sound. And the second matter, please feel free to ask questions to our panelists. The chat is on. We will be reading these questions, forwarding them to the panelists, and in the end of the session, I believe we have half an hour for each part, and the last, let's say, 10 minutes devoted to Q&A. So we will be using the time also to provide answers to questions that were not asked, or we didn't have time to ask in the meantime. So this is it as far as technical issues concerned. The first presentation, let's move on. When I spoke with Director Andrzej Porawski, we were speaking of good examples, and of course immediately the name of Bydgoszcz appeared. And since Bydgoszcz, then Mr. Stanisław Drzewiecki was immediately invoked, a person who is the chairman of the Municipal Water Supply and Sewerage Administration in the city, graduate of the Poznań University of Technology, but for 30 years related with Municipal Water Supply and Sewerage Administration in the city. He also received the title of the Resident of Bydgoszcz of the Year in 2024. When he received this title, it was said that he's a man who does not only create the economic power of the city, but also introduces a lot of energy, vision, and unique personality to it. We can see this personality in his approach to work. Let me quote his words from a few years ago when speaking about sewerage. He says, yes, this is a service for the residents, because we have an incredible opportunity to create for them something that is the most important, that is safe and clean water in their taps and clean natural environment. Especially important is to create a sponge city, that is the development and expansion of infrastructure protecting the city from the consequences of climate change. I hope I didn't misquote it, so let these words serve as the introduction to this presentation. Sorry for the time limitations. Mr. Chairman, the floor is yours. Thank you so much. Welcome everyone, and thank you for having this opportunity to present our project, our sponge city of Bydgoszcz. And thank you for these kind words on behalf of our company. Bydgoszcz, the sponge city. Excuse me, we have a small technical issue. Climate change is a fact. Regardless of what the deniers say, we have proof of it everywhere, whether it's flooding or droughts, even the waves of frost that we're experiencing right now. And in order to counteract them, combat them efficiently, we need pragmatic, systematic, and consequent activities. Our company is responsible for over 500 kilometers of stormwater drainage system. The multi-level system, 224 kilometers, which were quite well maintained, were a good example, in our opinion. And to that, we had to add the single system that was acquired later on. And today, we can speak of the situation with such an equation. It's the bad maintenance system of the drainage, high intensity precipitation, loss of natural retention, and we see the consequences below. City flooding, city inundations. The state of rainwater sewage is especially due to the fact that it was badly designed. There was a wrong methodology by Professor Błaszczyk even before the war, so it couldn't handle the pressure from the very beginning. Later on is the creation of the catchment areas, technical condition. You see the statistics here. So it's, as you see, we acquired from the roads administration a large part of it. So 75 kilometers was silted up in almost 80%. In 1958, the year where I was born, most wells were filled with soil or flooded with water. So you can see the scale of the problem and the state of the system. It didn't work correctly at all. So when we acquired the network, we undertook systematic cleaning, audits, construction works to drain the systems, to make them operable. I presented in the form of these milestones here, which is our special approach, this programmatic and spatial study of the rainwater drainage system in the scale of the whole city. Already in the year 2000 was the first step. So quite a long time ago, 25 years ago, we commissioned a study so that in 25 and 50 years we could introduce the necessary changes. At that time, we made the crucial decisions to create the network and to create facilities and tools to clean rainwater. At that time, we undertook hydraulic calculations and simulations for the first time using computer technologies for the first time. In the cohesion, thanks to cohesion funds, we created a rainwater drainage system, and the most important element was 2013, when the City Council undertook the resolution of commissioning the municipality's own task to our administration, which was a proof that there was the awareness among the city council how important this network was. And of course, we received the necessary funding for the preparation works to solve the problem in the modern way, using the modern solutions. Another important element was inventory and technical condition assessment, valuation of the rainwater system, in order to be able to acquire the whole infrastructure from the financial perspective, then development of local precipitation models with a forecast of changes until 2050, and performing hydraulic calculations and computer simulations with the existing and future network in order to arrive at solutions, systematic, complete solutions. Another step where we are right now is the implementation of a project of retention and management of rainwater. We decided it's necessary to implement. The question is, what is the standard we want to achieve? And this is specified by the Polish European norm that speaks of the permissible, acceptable frequency of overflows. And it was decided that in city centers, service and industrial areas, no less than once in 30 years, there can be a flood, a spillage. As you see the statistics in these 5 crucial parts, sometimes we have them twice a year. So very much above the norm. Very important activity. Technical inventory. That is a very important first step. The first analysis and the discrepancy between them and the reality showed us that technical documentation is not necessarily valuable. It turned out that 30% of data on geodesical maps that are the basis for all planning or exploitation activities, 30% of data was simply wrong. So imagine that these hydraulic analysis or designs, well, they were really handicapped from the very beginning. Another important element was the local rainfall model that had to be created, especially for larger cities. It's absolutely necessary. Observations from at least 30 years were needed. We had them for over 50 years. So as you can see in the graph, we didn't know which of those rainfalls to choose. Of course, we had to employ scientists, Professor Paweł Liszner, a very important person, great specialist in the field of planning and implementation of this infrastructure. Mathematical statistics helped us to choose 5 specific rainfalls that formed the basis for the analysis. The part in the middle shows us the comparison with the Błaszczyk model that was mostly used before. The red is this was the blue one. The red one is or orange is the current model. So it's still in the first scale, once a year, twice a year. And so the right model should be correct. But when we speak of rains with very heavy intensity, as I said, causing floods, causing overspill, so there is a big difference because this is 30 to 40%. So if we raise the Błaszczyk model to those prognosed one for 2050, the differences, as you can see, are huge. So this shows how important it is to provide models for every municipality. Then, of course, we had to assess the soil infiltration and rainwater retention. The Polish Geological Institute provided a digital model, terrain model for the city of Bydgoszcz, where we identified the utility of soil for infiltration and retention, to accumulation of water, rainwater especially. Further on, using digital terrain models, we identified using computer applications the areas, the catchment areas or drainage areas, and this helped us to connect certain areas where hundreds, thousands of people live to different segments of the rainwater drainage system. The tools we have help to automatize this very difficult, time-consuming process, and it helped us to map the real situation in the system, depending on the level of groundwaters, catchment area capabilities, etc. Then we moved to another stage, which was the engineering analysis, creation of a multi-dimensional model, then accepting a precipitation scenario, creation of a digital model of the area, and integration of all these elements. And the last moment, also requiring a lot of effort and work, that is balancing the system and simulation of solutions. This tactics helped us to show that we're still in the state of initial works, in the hydraulics, of floods. So we had more unknown than known elements, but the practice showed that looking for an optimal solutions is by trial and error. For a standard catchment area, it's about 60 simulations to find the optimal solution. So you have to have the necessary experience, the experienced engineers, and in the unit that undertakes such a task, you need a team of people who are able to create such models, manage them, operate them, because this is not only a stage of planning and designing, but also a use and exploitation. An exemplary situation, one of more difficult catchment areas in the center of the city. Twice a year we have had floods. It should only happen once in 30 years. So we undertook an analysis of that area, created the model, and that was the situation before the investment, before the changes. Here you can see the hydrodynamic model and this balancing that is very important to receive comparability between this digital model and the reality, so we can be sure that our solutions are sufficient. So we analyzed for each catchment area, we analyzed different solutions with regard to hydraulic effectiveness, investment costs, exploitation costs, and the availability of the land for modernization solutions. We analyzed 3 solutions: retention reservoir, discharging water to hydrophytic deposits in Witos Park, large diameter relief collector, and retention reservoir with network regulation. After each simulation at the hydraulic level, we provided an engineering concept, technical and economic concept, so that we can compare the real analysis of costs and activity of the investment. And as an effect, we chose the solution that is the creation of underground retention reservoir with a total capacity of almost 3,000 cubic meters with network regulation, requiring minimum investment, first with simulations, then based on practice that we've had in the last few years. We showed that regulation of flow and connections between these channels, ensuring certain directions of movement, we can achieve a significant increase of capacity. That's how it looks in practice. All those analysis, engineering concepts, and methods helped us to define the scope of the project, of the investment project, the implementation of which helped us to meet the requirements of the European norm and also the expectations of the residents. What was particularly important in this approach is to have a total look at the infrastructure from the perspective of the entire city, looking not only today, but in 25, 50 years in the future. We need to plan this infrastructure in such dimension within the scale of the whole city so that we can optimize the whole system, because the system works as a whole, not only independent parts. If we don't have a concept for the whole network, with retention reservoirs or not, because all the local solutions may be just misled or simply provide solutions to local problems. So we need a total whole approach for the entire city. And with this perspective, as I said, for 25 and 50 years in the future, the activities that we undertook helped us to ensure this scope of the project. However, the economic aspect made us divide the program into two stages because of the scale of investments. That, of course, we would not be able to ensure within the framework of one EU perspective, or the financial possibilities, acceptance of the costs by the residents for providing the service. Of course, this is due to different criteria. That's why we spoke about these two stages. And all those analysis and solutions allowed us to define the scope of the investment project. We undertook the necessary analysis, feasibility studies, and we applied for EU funding, receiving very good opinions, but also, what is more important, the money, almost 300 million Polish zloty, the total net worth, and the EU financing almost 180 million. This project was completed in 100% by the end of 2023, whereas the second stage is now in development. Its particular feature is that while the first stage was done in the framework of this hard infrastructure, this time we collaborate with the city, and the city focuses on broadly understood green infrastructure, management, use of rainwater, and the second stage, and you can see the financial data, the total net worth allows us to modernize the whole system of rainwater management. This is over 515 million Polish zlotys with the EU financing of 345. This is the scale of the problem and the scale of needs. So we can see it very clearly here. It's not a project for 2-3 years, maybe for a decade or more decades. So it needs to plan, but also to implement with a lot of consequence and determination to achieve the optimal solution, and also to use these huge amounts of money rationally. The whole project requires to build 73 retention reservoirs, hence the sponge city. In 28 cases, we're building installations to treat rainwater, because without treating it, it cannot be used. We're creating a rainwater channel, 16 kilometers, some were renovated. From the network we acquired from the road management company, 90 kilometers needed to be renovated. 248 kilometers acquired from the city. Some of them needed to be renovated or cleaning. So now we have the entire network, rainwater sewage network, in our hands, and now we know it's clean and controlled. The monitoring and retention control system using AI, rainwater management systems, this green and blue infrastructure, a small retention reservoir is about 30 thousand cubic meters, more or less. So this is the plan of the city, how it looks. This is the very center of the city, where this construction is most intensive, when there is a biggest deficit of needs. The concept of intelligent control of the drainage system is a very important concept. By defining an investment project, especially from the engineering perspective, we decided that classic control systems, if A is B, if B is C, then it won't work. It won't bring any necessary result. That's why we decided to make another step, to hire scientists who help us find a solution, that is to use an expert-based system based on neural networks. Due to very complicated geological, hydrological processes in the ground, not even a large group of engineers could manage it on a permanent basis. So from another EU program, it was co-financed, it was implemented. Speaking very plainly, simplifying, it helps with the use of AI, having the history and the current state, knowing to what level the reservoirs are filled, but also including the data from meteorological radars, what kind of rain can be expected 2-3 hours ahead. They calculate on a permanent basis, providing dispositions whether to empty or retain the water in the reservoirs every dozen or so minutes, every quarter more or less. So this hydrodynamic model is permanently updated a few times an hour, managing the level of use of reservoirs and the expected precipitation. Another challenge, the creation. We had 147 facilities in the city center. Very often these were squares, streets, car parks. It's a huge challenge. It had to be perfectly organized because it did disturb the functioning of the city necessarily. And this stage is behind us. What is most important here? In summary, you can see the statistics, how it used to be. Before we undertook the project, we had 10 floodings per square kilometer a year. After the investment, 2024, it was less than 1. Last year, we had 2 very intensive rainfalls. There was no flooding at all in the whole city of Bydgoszcz, which is a proof that the system has been improved. It works. We're still providing new elements, so we hope it will be even better. What is more important, after creating the system, so that we don't slide back, wasting a lot of money on renovations and cleaning, we created a rainwater channeling network system unit. And in their network, we already have to some extent 250 technological facilities that require automation, and the automation unit is responsible for the management and conservation of the system. It's also supported with AI. The price. Well, imagine managing this infrastructure in the proper way as the residents expected, and at the same time provide investments without paying, without prices. This would be impossible. We have the price provided by the city council. The calculation method is the same for the water and sewerage system, so that we don't slide back to the previous state. That was mostly due to the fact that there was not enough money for the system, so everybody has to pay a price. A very troublesome, time-consuming process to identify the areas ascribed to each owner so that it can be invoiced. Very difficult, a lot of work, because using the app, we had to analyze tens of thousands of properties, areas, surfaces, for drainage, and depending on their size and the price per cubic meter of water, we had to provide invoices. In 2-3 years, as you can see in the graph, we were still on the way to reach the target level. We still have 4% of the city area that still needs to be finished, but well, we need to complete it anyway. Rainwater. The state as we receive it, of course, makes them unable to be used for any use. So we elaborate a technology. We worked on it in many catchment areas, tested on many types of rainfalls, and this technology is available in practice in our standards, so that we can use this water for free by anybody who's interested. Quality of the rainwater. There are two parameters. That is carbohydrates from oil, sludges, different kinds of fluorantans, WWA, lead, and this sounds dangerous, but interestingly, from our research, we see that this is mostly related with the sludges, suspended solids. So the quality is between 40 to 84%, on average 55% of these sedimentation, of these pollutants can be eliminated by proper sedimentation. So we need sedimentation tanks for this initial partial cleaning of rainwater if it's correctly designed. What is ahead of us? The balance of benefits. According to the analysis, we see that in the beginning, 3,500 buildings, 77 kilometers of roads and streets were in danger of flooding. Potential losses within the framework of 20 years were calculated at a level of 722 million Polish zlotys. The investment, as I said, costs 515 million. So you can see the difference clearly. Different solutions, very interesting ones. For example, we built 10 ponds in the system that in the past were full of clean water, fish, wildlife. But after cleaning, after renovation, we connected them with the rainwater system, and they are functioning now as water reservoirs when there is too much, but also providing facilities, providing possibility for life, also for aesthetics. This is also important. You can see how it looks here. The outlets. We have two very interesting elements. That is the pump hole and the old water tower, where we provide ecological education. This is very important. It's not only infrastructure, but also educating and informing the residents, repeated to maintain their level of awareness, understanding, to show them how everybody can participate, because everybody can use it. Using, for example, rainwater without draining it to the sewerage system. It is very important in order to ensure why it's necessary, why all these difficulties with the investments, closing the streets, etc. It was of particular importance. We also provide educational activities for children and adults. We participated in the City Water Circles program, providing elements of green-blue infrastructure. It's a great place to show these issues very realistically, very hands-on. You can also see the Sewerage Museum. As far as we know, it's the largest museum of this kind in Poland, so feel invited to visit us one day. To give you another example, we treat our project not that all the possible solutions are included, all the needs, all the problems, of course not, because we do not interfere with the private properties. This belongs to their owners, but we provide examples. Here is the use of rainwater for a fountain in front of the Philharmonic. a very interesting idea of the city. At this stage, we ensure that there is green-blue environment infrastructure for 4 schools to have a tangible example how it works. And the city is working on solutions for 120 schools to create such enclaves areas at the target environment level in the city, very closely connected with rainwater. The 5 ponds valley source of the city in the Middle Ages, in the past, completely devastated. Now we want to bring it back to the original clean state, but details maybe at some other time. We want to provide such changes as you can see in the picture now, managing the area also with the use of rainwater, and the city provides this green infrastructure, greenery works. We also want to show how we approach these issues, and also for us it's an exemplary solution for areas, especially those that are devoted to services and industry. This is our headquarters at Toruńska Street, where we are also going to use rainwater for cleaning the sewerage system, cleaning the cars, and also to support the greenery for watering the plants. Some photos from meetings with the youth, where we speak about the use of rainwater in natural environments. And just to finish, sorry, I haven't noticed this red line. We had lots of questions after the meeting. There were many representatives of similar companies like ours, local governments, and we thought it's going to be best if we write it down. And we created this publication that you can see, the Bydgoszcz standards for rainwater. It can be obtained by contact with us. It cannot be bought in libraries, bookshops. So we gave out all the printed out versions, but we'll have another edition very soon. So feel free to contact us by mail or phone. We'll be happy to send you a copy. In order to move from this green-blue concept to practical solutions, we provided a guide of practical solutions for green areas. We have 20 different solutions with measurements and tens, maybe hundreds of photos, how these solutions look in practice in different scale, whether it's a small park to huge facilities. Sorry for speaking longer. Thank you very much, Mr. Chairman. It was a big challenge to say and show so much, such complex approach in such a short time, from the acquisition of the infrastructure to implementation to these particular solutions. As when I was listening to you, I can see that Bydgoszcz moved in practice from this classic approach, you could say, dating back to this 19th century of sewerage that just collects the water, to absolutely modern, cutting-edge approach based on technology, using different models, AI, or measurements that help to manage the system on a digital basis. Still remembering these different dimensions, because it is one thing if it regards the entire infrastructure investment, but also the context you mentioned in the end. So collaboration with the residents. We're about to pass the floor and listen to our Swiss guests to see how it works from the Swiss perspective, because you said something that the residents where they live can also add, and they have also participated in the management of rainwater. But before we pass the floor to our Swiss colleagues and listen to the experiences of St. Gallen, Tomasz Piątek is about to connect us. But I would like to point your attention to one question that appeared very briefly. Whether in order to have rainwater gardens, you received the official water law approval. If it's brief, shorter. If I may, very, very quickly, since you will not be able to see those facilities, and we have a short video, 90 seconds, where you can see how it looks. I'd like to ask you a favor to show the video.
pan tylko udzielić odpowiedzi na pytanie.
Oh, yes, we will, but just please provide the answer. Do you need a water law permission? No, because there was no situation that we needed it, because no rainwater is led, conducted into the ground, into the soil.
W każdym zbiorniku jest separator. Wody deszczowe kierowane do zbiornika są oczyszczane, zawiesiny tej grubej, dużej substancji pływającej.
Each tank has a separator to divide the clean water and sedimentation.
Szanowni Państwo, pojawiały się pytania na czacie i prezentacja i Bydgoszczy i wszystkich.
There are some questions on the chat. All the presentations of our today's speaker will be available on our website.
Tam też zapraszamy do przyglądania.
This is where you can also have a look at those different topic conferences that we have already had related to this area, and not only, there are also recordings. So you see, it is all automated. There are periodical maintenance checks once or twice a year, but the whole system is automated. It's fully automated. Nie słyszę.
Burzenie wody deszczowej i zatrzymanych osadów, to pozwala je usunąć ze zbiornika. One są później separowane.
We can take those sedimentation rests away from the tank. We have a special system for that.
Z poszanowaniem środowiska. Panie prezesie, bardzo dziękujemy za prezentację.
Thank you all. Thank for your presentation. Thank for this short video. And now, as it has been already announced, we would pass to St. Gallen. We have Tomasz Piątek with us, who is the engineer of architecture and infrastructure. But in St. Gallen, he is responsible for supporting projects related to the city, the concept of Sponge City, but he will also share the implementation with regards to this experience in St. Gallen. And also within his duties, he plans the sewerage network and the geographical system management, GIS, and as we have already said, Mr. Tomasz, we are very interested in your experience, but we have a kind of a continuance because we have had this in Bydgoszcz as well. But now we are very happy to see how in a town we can build this engagement of the local in residents. We can also ask, is it possible to develop the Sponge City concept without the engagement of the citizens? So I will give you the floor. My name is Tomasz Piątek, and I have the pleasure of showing you today the concept of Sponge City in Switzerland, and especially in St. Gallen. In my presentation, I would like to introduce to the Sponge City concept, to talk about the challenges that we face, and thanks to what kind of help we can face them. I will talk about the concept and within the heavy precipitation context. I would give the summary of Swiss Sponge City experience, and I will say in more details the St. Gallen's approach to the Sponge City. Switzerland, but not only, actually, the whole world are facing different challenges. One of them are changes in the climate. We observe that the extreme weather conditions and precipitations are getting stronger. They are interweaved with droughts, long dry periods, and heat waves. Another big challenge is the population growth. In the Swiss towns, they grow significantly and fast, and what is very characteristic is that they grow inside, which means they become more and more dense. Within the same limits, we have more buildings, and this is a very dangerous phenomenon because it can lead to sealing the existing surfaces, green surfaces. Another aspect is the biodiversity problem crisis and the water protection. The sponge city is supposed to restore the natural water cycle. When we see it in the picture, in the right-hand side, the evaporation is the main factor that is responsible for becoming the water coming back to the cycle. We have the plants also that take the water, and later on we have this process of evaporation. The trees are the most important factor here. The slower impact has also the infiltration, drainage, because only as some part of precipitation water is getting through the surface system. In the cities, unfortunately, the process is being reversed. The water has no time to evaporate. The sealed and concrete surfaces do not enable them the infiltration, and the very precious and needed water is treated as a problem, and through the surface system it goes to the sewerage. And the point of this sponge city is to inverse this disadvantageous phenomenon. How can we do that? How can we head towards it? There are many ways, but one of the most important ones are making the roofs and the buildings green. I think it's worth having a little more time and details that, because in Polish cities very often this is not possible because of the law. For example, the roofs have to be the slope roofs, whereas even ones they are the most important one from the water retention point of view. For example, we should create water tanks in number 3, 12, and 4. The underground tank can also be used to water the greenery in the cities when there is not enough water. Another important activity is creating ditches, for example, also creating car parks without sealed surface. And another important element, as I have said, are trees, because not only they do gather a lot of water and enable it to evaporate, but they also give the shade and coolness during the very hot times. What are other advantages of a sponge city? There are many, of course. They reduce the surface runoff and they give less load on combined sewers. And even though the city gets more dense, we do not have to make the sewerage channel system bigger, so it reduces the cost. And it also reduces the stormwater overflow, which is also advantageous for the sewerage system. The cooling through shade and evaporation, thanks to the trees, thanks to their leaves. And also the sponge city creates an attractive and livable public space, as well as it increases biodiversity. The sponge city is supposed to manage somehow the heavy precipitation and hydraulic overland scenario due to also normal atmospheric phenomenon. But also, as I have mentioned, there are extreme precipitation events, and then the sponge city, in this case, is not able to, cannot cope with this extreme precipitation. So this is why it is so important while designing and planning, you have to take into consideration this element. In the picture, you can see the Marly and in Canton Fribourg example. It's a estate settlement design according to the sponge city rules. We see there are lots of green surfaces, many bushes, trees. There are some local elements. And if you see those blue lines, blue arrows, there are ditches infiltrating the water that can partially store the water and enable it to evaporate. As I have said, when there are some extreme precipitations, these solutions do not or not enough. So what is very important is to design corridors where the water could flow freely and without any problems when there are some heavy overloads. And another role, another important fact are those ditches that on a daily basis they store the water, and their task is to give this water away to some kind of reservoir. And we have to take into consideration few elements. One of the most important is the crossing of the ditch and the road. We have to make the proper passage for the water so that it can flow freely. And we have to remember that we should not plant too many bushes and trees next to those ditches because it could negatively influence the water flow. In addition to this system are local, we can see in some pictures, the application of special protection for buildings. For example, where we have underground car parks, so that in a very heavy precipitation, there are no inundation, no damage made. The Swiss experience. All Swiss cities, big cities, are implementing the sponge city measures in the last years. We are having lots of testing. We exchange our experience. It is a very attractive concept, the sponge city concept, because many synergies, many challenges can be addressed at the same time. It is enough to apply one solution, but it's also easy to communicate because the image of the city as the sponge can easily get through to the people and to our inhabitants. They understand it easily. And we see also the positive connotation with this concept. The pro-ecological activities such as creating clean transport areas, very often they are negatively accepted. They are negatively taken by the administration or by the cities. But in the case of the sponge city, we do not see such a phenomenon. It is always positively taken by the residents. Of course, there are some challenges related to that topic. One of them is the needed changes, interdisciplinary approach that requires the change of processes and responsibilities, because it is impossible to introduce the sponge city concept in just one unit, one department of the city hall. It's simply impossible. Those processes have to be led through cooperation and collaboration. So there are also new concepts and technologies that we need to build up the knowledge, and we also have some trade-offs. Their space needs, there is always not enough space. And very often the sponge city solutions take some place. For example, where we plant trees or we have a reservoir, we cannot create parking spots. So we also have to remember that the trees, they need a lot of place, not just over the ground, but also under the ground. and they have to compete with the underground infrastructure that we also have a lot of in our cities. And also what is worth remembering is that the accessibility can be also a problem, because when we have the unsealed surface for example, of the parking spot is not so available for people with disabilities when we compare it to the concrete surface. The sponge city, when building, it's also a little bit more costly, even though those costs very often within the time they are paid back. In Switzerland, as I have said, we have an exchange of experience, and it's very crucial. There are many associations, for example, VSA, Association of Swiss Wastewater and Water Protection Professionals, SVKI, Swiss Association of Municipal Infrastructure. They have their website where that we can see examples of positive projects related to the sponge city concept. Some companies are also, insurance companies are very interested because there are less damage, less money to be paid from the insurance. So some private companies are also quite interested. They support us, they give us their advice, but they also support us financially. Other measures or the sharing of experience within the canton of Geneva. Now I would like to talk about the St. Gallen more in details, where I live and work. St. Gallen is located in northeastern Switzerland, quite close to the Bodden Lake. The population is about 84,000 inhabitants. For Switzerland, it's quite a lot. It's a big city. It's like Konin in Poland. I would say Jelenia Góra, or rather medium towns, or even small ones. This is one of the highest cities, because the medium height is 700, 800 meters, like Karpacz in Poland, or even a little bit higher. The annual precipitation that we have, it's 1400 millimeters, so it's the double of typical precipitations in Polish towns and cities. In St. Gallen, we focused on private land, since they are 85% of the surface built area and also 70% of the runoff. What is important is the communication. We try to raise awareness for the sponge city benefits among our residents. We have also introduced specific regulations limiting the permissible rainwater discharge. Only 15% is the maximum, but it's only for new constructions that require new permissions or hard renovation. In order to have also influence on those buildings that already exist, we have our incentives. The Sponge City Fund supports private sponge city measures related to it, and it is financed from wastewater fees. We also have a decentralized retention basins program that makes our channels narrower, and all these concepts are covered by our units. We have also the concept of the green streets. Our goal, very ambitious one, is of having 30% of St. Gallen streets being covered by canopy. Now it's about 10%, but the systematical work and activity makes us closer to our challenge and goal. We also have a greening and unsealing of public spaces and neighborhood streets activities, and since not very long we have blue-green streets. It's starting now. We want to promote the green infrastructure combined with rainwater management in street redesign projects. As I have said, the very important element is communication. In these two pictures, you can see our stand in the local fair in St. Gallen, where we present our inhabitants the benefits coming from Sponge City concept, and we inform them what are the programs and funds that they can apply to in order to implement those activities, those solutions in their houses. Very often we meet, actually always we are very enthusiastically welcomed by our residents. And now a few private projects, the example of private projects that we have co-financed. For example, unsealing of a yard before. It was all in concrete. The infiltration and evaporation were practically impossible, but now we can see that this yard is being unsealed and all those processes are possible. Another example is a pond that enables retention and infiltration. It enhances biodiversity and cooling in the summer. Green facades, that's a very interesting project that not only helps the hydraulic part, but is also very aesthetic. And it helps to make our city more beautiful. And the fourth picture, you can see one of our most common projects, rainwater storage and use in such underground reservoirs. We store it, they can retain water and store water in order to water the plants. In this slide, you can see how we want to introduce the concept of green streets. We want to make them green, as the name implies. One of the examples is the project of St. Leonardstrasse. It is centrally located. It's a very important act of communication. Currently, we process the redesign. The goal is to make it green and also to use the water from precipitation so that it is according to the Sponge City concept. In the right-hand side, in the left-hand side, you can see how it looks now. On the right-hand side, the visualization, how it will look like, how it can look like in the future when we implement the project. In a few years, when the trees grow enough. Such slides, such pictures make our residents make it easier for them to understand, to see what is our goal, what are we heading to? In St. Gallen, we have a civil society initiative. This initiative, this association actually collects architectural agencies, private people, architects, landscape architects, and the aim is to create such project design so that we can make our city greener, how to enhance biodiversity, how our city could look like if we implement more of those Sponge City concept solutions. Here we have pictures how it looks like now at the moment, and then we have a visualization, what are our objectives, how these projects can be implemented. In our work, we use different planning tools. In the left-hand side, we see an example of soil infiltration capacity map, where we can easily see how the waters get infiltrated. It's very useful as a tool because it helps us to define properly the areas where we have to build ditches, infiltration ditches, where it makes sense, and also where are the places where there is no use of it, and we should look for some different solutions. Different projects. In the middle, you can see the flood risk, the risk map of flooding. If we have extreme precipitations, we see that a very big part is actually in risk. So this is why our activities are so important. On the right-hand side, you can see the thermal image integrated many many pictures in a very hot summer afternoon, and such pictures showed our residents where are the areas that are green are cooler when comparison to roofs and streets that have no greenery. And they also help us to define where are the heat islands in the city and to define where we should focus on in our future activity. As I have said, the Sponge City is an interdisciplinary task. A lot of activities are us, I would say, the urban drainage, but we cooperate very closely with the road engineering, the infrastructure. The greenery department is also very crucial here. Their task is to plant the trees and bushes, planting, and we also cooperate with urban planning. The whole is closed, as we can say, but the communication and the public relation department that communicates all our activities to the residents. And this is all what I wanted to share. Thank you very much for your attention.
Dziękuję bardzo. To była taka prezentacja.
Thank you very much. It was a presentation where we could feel that you share your experience, personal experience. It was not just by an expert talking to us. I would just like to focus on for a moment on challenges when implementing these sponge cities. As you have said, in Switzerland, it's quite common. What was very interesting was those different places where Swiss towns can share their experience, where they can share the good practices among each other. But when we talk about compromise, there's this interdisciplinary phenomenon because we can't work for it separately. We fight for a very limited surface, but the sponge city concept also needs to limit some other places and elements. And as you have underlined very strongly is this communication idea. Even though the residents accept it easily, it is not politically connect, it is positively connect, and this approach usually works very well for the residents' imagination. And also you have mentioned the planning tools. For example, the percentage of trees, surface covered by trees, your goal for 30%. You have talked about maps of soil infiltration, green streets, and just let me ask you one question. What today, from your personal practical experience, is the biggest challenge that you face? If you were to talk just about the tasks that you think that, in your opinion, are the biggest challenge in the Sponge City concept introduction. And the second question, in the City Hall of St. Gallen, you are the project manager in the sewerage network planning department, but is there any unit that coordinates the activities of the climate change activities that we have to implement? Is there any unit that combines, enables the cooperation? Yes, so I think the biggest challenge for the moment are the climate change. So heavy storms, heavy waterfalls, and those extreme phenomena that are more and more often. They used to be, for every 40, 30 years, now we see them every few years. So it's a very big challenge so that we can deal with this challenge. And also the increase of the temperature. There is drought. The summer are getting hotter and hotter, and the fact of that we have to cool the city is also a very important element of the city, the Sponge City. When it comes to the second question, when it comes to the Sponge City, We are the leaders here. Our drainage department is, let's say, the crucial one, but we cooperate very closely with other departments, and we take care. For example, if the street planning department wants to renovate something or redesign, we enter there. We offer them some solutions, how we could implement the smart city into that. If the greenery has some designs and projects, we also cooperate with them, and we try to implement as many activities as possible to enhance the hydraulic situation in our sewerage. So your experience will stay long with us, I know, but when you have said that, if you concentrate on private land, so these are the requirements that you want to limit, but also the incentives with support, financial support, and supporting also the private investors. And a formal question I have, it is engaging public funds in private area. Isn't it a problem, a legal problem, that you use public funds in non-public areas? No, there is no such a problem, because we have our law, the city law, that defines very clearly how we can apply for such a financial support, what activities are supported, what are not, how do we calculate the financial rate. So it is all very clearly and transparent, and there is no such a problem here related to this public and non-public finances. I would even say that our budget is even higher, that we actually share the money with private investors. So we are really trying to help those who apply, so that the biggest amount of people can benefit from it. The time is getting short. Thank you very much. I would just like to remind you that this presentation with other representations will be available on our website. Now we will go to our next point. I would like to invite Alexander Southhoff, landscape architect in Montreal University, graduate, and he's specialist in urban planning focused on increasing climate resilience, and he has a very rich experience in Canada, in Switzerland, and in South Africa Republic, always combining designing and new research. His experience is very rich from the very beginning, like planning to implementing. And in his approach, he says that the biodiversity is the crucial element that decides about the climate resilience and the quality of life in the cities. In his presentation, he will be talking a lot, so I would just like to pass the floor to Alexander. The floor is yours.
Dzień dobry, and thank you for being here. All right.
Okay. We can see your computer screen, and now we move to...
Can you see the presentation?
No, not presentation yet.
I'm sorry. No. I'll just go back to it. There you go.
Okay, it's perfect. And
now it's perfect.
Okay, now it's okay.
Can you see the full presentation?
Yes, yes. We've got view. Perfect. Thank you.
Then dzień dobry, and thank you for being here. Thank you for this introduction. My name is Alexander Southhoff. I said I'm a landscape architect based in Lausanne, and with a long-standing interest and also experience in climate adaptation, biodiversity, and sustainable urban development. So this presentation focuses on integrating biodiversity into climate resilient urban planning. Cities today are increasingly exposed to climate risks, as we have seen in the previous presentations, and also to growing pressure on urban infrastructure. While these challenges are often addressed through, I would like to say, technical solutions, there is a growing understanding that nature itself can act as infrastructure. So the concept of the sponge city was recently presented by Tomasz Piątek and has highlighted the need to enhance the perviousness of urban soils and to improve infiltration of runoff water, and also limit urban heat islands. And all these ambitions, they share a common element, which is the role of vegetation in urban areas. In this presentation, I will focus on biodiversity as a climate resilient infrastructure, not just as an added amenity, but as a functional system that helps cities adapt to climate change by cooling areas, managing water, strengthening overall resilience, and also improving quality of life. And integrating biodiversity into urban planning means rethinking how we design and manage cities, from public space and streets to water systems and soil. So to make this approach concrete, I will present case studies from Lausanne and other Swiss cities where biodiversity has been successfully embedded into climate adaptation and urban development strategies. And these examples, I hope, will help us explore practical planning approaches and also transferable lessons that can support climate resilient urban planning in different contexts, such as in Polish cities. To frame this discussion, I would like to start with a statement from the United Nations, which says green spaces don't exist just to beautify urban areas. Trees are the lungs, liver, and beating heart of the world's cities, and they are fundamental to creating healthy, livable, and sustainable cities around the globe. So this perspective reminds us that urban nature is not just decorative, it is functional infrastructure. And that is the lens through which I would like to approach urban biodiversity today. Building on that idea, it's important to recognize the scale of the challenge we are facing. Climate change is a global phenomenon, as it was said, but its impacts are especially visible in cities. For example, in Switzerland, projections indicate that average temperatures could increase by 2.3 to 4.4 degrees Celsius by 2050. And this warming is not just a number, it translates into more frequent and intense extreme events such as storms, droughts, floods, landslides, all of which put pressure on urban infrastructure and also on public health. So cities are especially vulnerable because most people live in urban areas. In Switzerland today, for example, 82% of the population is urban. And similar trends can be seen across Europe as well. And this concentration of people and infrastructure means that climate risks can have amplified impacts if they are not addressed proactively. Looking ahead, there are two key factors that will shape our cities in the near future. First, cities will need to be resilient to extreme climate events, which are becoming more frequent and intense. Second, we must focus on reducing the carbon footprint of our urban areas, because how we build and operate cities directly contributes to global emissions. And one urban challenge in this context is urban overheating. Then cities tend to be much hotter, which is not new, than surrounding areas, which is the so-called urban heat island effect. Without effecting cooling strategies, heat waves pose serious risks well, to public health, energy systems, and overall livability in urban areas. So this is exactly where nature-based solutions and urban biodiversity come in, as you can see on the right image, where you can see the planted street. Now, let's look at urban biodiversity and how it contributes to climate resilience. Trees, woodlands, and other green elements do far more than just provide shade or adding aesthetic value. They can be considered active infrastructure. They produce oxygen, purify the air, capturing fine particles that would otherwise be or would otherwise affect our health. They absorb carbon dioxide from the atmosphere and transform it into biomass. But for example, wood, foliage, or the roots of trees, and help reduce the city's carbon footprint. And they also help reduce smog days, especially when temperatures rise above 18 degrees Celsius. And crucially, they buffer floods and manage stormwater naturally, reducing the impact of heavy rainfall and extreme weather. Trees and woodlands also help cool cities. Well, first, they reduce urban heat islands simply by providing shade. But the cooling effect doesn't stop there. Through evapotranspiration, trees release water vapor into the air, which actively cools the surrounding environment. So research shows that this cooling can be significant. For example, while temperatures can drop by 8.7 degrees within just 20 meters of dense trees, and trees on asphalt can reduce felt temperatures by about 4.5 degrees Celsius. Or for example, a single 14-meter tree can lower temperatures by 6.6 degrees during the day and 2 degrees during the night. Beyond climate adaptation, of course, multifunctional green spaces bring a wide range of social and also ecological benefits. Of course, they improve our physical and psychological well-being by creating environments that encourage outdoor activity, for example, walking, running, cycling, you name it. And also by providing spaces for relaxation and stress relief. So green spaces have this therapeutic effect, helping people recharge and also maintain a mental balance. And at the same time, they add value to the city, not just for people, but for urban wildlife as well. And from a planning perspective, these nature-based solutions, they are also cost-effective long-term investments because they reduce heat, they manage water, they improve air quality, enhance quality of life, and all at the same time. This wheel of urban biodiversity summarizes just the multiple benefits and ecosystem services that are provided by nature-based solutions. So I'll just let you look at it. For example, in terms of heritage, the older the trees grow, the more value they would add to a neighborhood, for example. And they can be nourishing, they reduce heat islands. So this is just a graphic about a summary of what I've just said before. For urban ecosystems to function effectively, it needs different vegetation strata. For example, natural forests are layered, and when cities reproduce the structure, green spaces have much more like or become much more like living ecosystems in the city. So they are able to adapt and to regenerate and also to withstand stress much better. as if you would just grow one single tree, for example, without any herbaceous layer at its foot. And at the top, so there's the canopy layer, which is formed by tall trees, which would provide shade and reduce heat and protect the layers below. And beneath the canopy, there is the shrub layer and the herbs and the ground vegetation that also play an essential role because they retain water, they support urban biodiversity and create also cooler microclimates. So the key point is that a layered, diverse vegetation structure is far more effective than a single type of plant. And more layers so means more ecological niches, means higher biodiversity. Now let's look at practical examples from Lausanne and other Swiss cities. The EU Biodiversity Strategy 2030 calls upon cities with over 20,000 inhabitants to develop urban greening plans that are aiming to bring nature back into cities and to support biodiversity and also tackle climate change. So today, across Europe, many cities have developed such urban greening plans, and these plans are not just about planting trees randomly. They set clear goals and identify priority areas. These plans can include technical guidelines, tree charters, biodiversity plans, and even requirements that will be integrated into public tenders, and all to make sure that green infrastructure delivers climate resilience and social benefits. Equally important is, which was also said before in the presentation, is the interdepartmental collaboration in the municipalities. For example, the urban planning department, mobility, water management, and green space teams, they all need to work together to make these plans effective. Here's just an example of the city of Geneva that has adapted a bunch of different strategic documents, tree surveys, and planning principles, and that would all translate into short-term, mid-term, or long-term planning principles. And we will see this by the example of the city of Lausanne a bit closer. So, which is a very interesting case study, is this canopy plan, which was been developed by the city of Lausanne. The objective of this plan is to significantly and sustainably increase the city's urban tree canopy, which is, well, the layer of foliage and which is the tree crown, if you want. So the canopy plan is a strategic part of the municipality's broader climate plan. So its main objective is to increase and to strengthen the urban environment and its quality, to enhance the climate resilience, and to boost quality of life for urban dwellers. However, this requires a systematic and also well-planned approach to ensure a long-term impact. So the city of Lausanne has started with an assessment of the existing tree cover, because, well, you can't manage what you haven't assessed before, and so the trees has measured its trees, and more specifically, it has established a baseline assessment. So by measuring the surface area that is covered today by their crown, so by the tree canopy, and this area represents today, or from 2012 on, 20% of Lausanne's urban territory, excluding rural areas. And to cool the city more effectively, well, Lausanne aims to reach a 30% canopy cover by 2040. So to achieve this goal, it is necessary to increase both the number of trees, but also their size, and to make sure that these trees are being maintained and not being replaced by younger ones. So the map to the site shows the inventory of the planted and the unplanted trees of Lausanne by 2012. So the city has then identified priority actions for all the different neighborhood typologies. For example, green corridors along main routes. The objective is to plant generously and to create landscape continuities at the city scale that run through different urban fabrics. For streets in neighborhood or in housing estate neighborhoods, the objective is to create a park-like atmosphere and to choose large growing trees that are suited to the scale of the buildings, and to make sure that there is room for vegetation within the mineral spaces. Other typologies would include streets in neighborhoods close to parks and forests. The objective is to extend the forest or the park atmosphere into the streets, and to promote tree planting in parks and forests for the benefit of the street space. So as if the forest or the park nearby would just grow over the street and would be part of the neighborhood. Another typology are the streets in neighborhoods of contiguous buildings. The objective is to provide the impression of a tree-lined avenue, and with the maintain of the continuous vegetation, to diversify plant species and vegetation layers, and to create sequences of varying density. Then for single-family home neighborhoods, the city of Lausanne would like to convey a garden-like character. So that means that they would plant solitary trees or in small clusters, and which allow for natural growth and expansion, and create also a green continuity, and to encourage private plantings to also extend onto the public street space. For example, a tree that would just be close to a fence of a house or of a property, and it would just, with its canopy, grow over the sidewalk and provide shade. Streets and quarters in the city center is another typology. So there, the objective is to punctuate streets and squares with prominent trees, to plant large solitary trees or small groups at open spaces and intersections, and to enhance the tree canopy of public squares. So concrete actions, for example, on Avenue de Provence in Lausanne, that involve the transformation of the central median on a major urban road with major trees. And of course, it also adds aesthetic value to the city, especially when you think of a major road where people would enter into the city. So to assess the existing green, Lausanne uses LIDAR technology as a key tool in assessing and also managing its urban tree canopy. So LIDAR stands for light detection and ranging. And LIDAR is like a remote sensing technology that uses laser pulses that are emitted from a drone or from a plane, for example, to measure distances to surfaces. And it then creates a high resolution 3D map of the vegetation, and which allows to have a better understanding of your green cover of the city at the whole city scale. And and then these data can be complemented and validated through ground-based surveys as well, by the help of botanists and landscape architects, for instance. So here's just an example to show what it looks like when you have assessed the tree canopy using LIDAR technology. So there, for example, you would just see the whole foliage cover. On this slide, you can also assess the height of the different trees, for example, here up to 33.5 meters. And that shows where is a high density of high trees and where high trees are lacking and where more trees should be planted and where the tree cover is insufficient to provide its ecosystem services. So how can the existing green asset be assessed? So analyses are usually carried out by GIS tools, and they focus on overall vegetation cover, for example, the canopy surface area and the volume. And you can also do this by different vegetation strata, and also by the identification of areas with dense vegetation and those where, well, a reinforcement of the vegetation is required. And it also focuses on the overlay of cadastral data, so to determine canopy cover rates on public land and also on private land. And by repeating leader scans annually or every 2 years, like periodically, while the city can then track the tree growth, and they can then, well, take decisions on if the canopy expansion is sufficient or if there's any loss due to whatever diseases, to storms, or damage or construction. And well, to complement the quantitative survey analysis, well, you can also make a qualitative assessment. So that means that you can then measure or evaluate the condition of the trees, the health, the structure, the diversity of the urban vegetation, the different strata. And yeah, and then also conduct more surveys if needed by means of landscape architects and botanists that would just go and assess the different trees just to complement the GIS survey. So here's just an example of the city of Zurich, and that is showing again how the city is assessing its tree cover. So by means of LiDAR technology, using planes or using drones. And for example, that helps to assess that, for example, for a park, we have 40 to 50% of the canopy coverage. And in a neighborhood, for example, there is maybe 30%, and to obtain the objective of maybe whatever 40% for a neighborhood area, that means that there is still more need for trees, for new trees to be planted. So both Lausanne, Zurich, and also Geneva, they are actively adapting their urban forests and their green spaces to respond to climate transition towards a more Mediterranean type of climate. In fact, our climate will become, well, closer to that of the Balkans, as you can see in the graphic below. And we believe that this will happen by the end of the century. So you can see in the example of Geneva's climate transition that it will, well, that it will become more closer to the Mediterranean climate by the end of the century, which makes many traditional temperate tree species less resilient, with higher risks of diseases, drought stress, and also dieback. And this factor is therefore very important to bear in mind when choosing tree species and when defining future trees for our cities that will thrive and that will still survive in the decades to come. So therefore, the cities, they are adapting their tree lists of trees that they would usually plant by not just planting indigenous trees, but also to plant trees that are known for their high resilience in the city, where the climate is much more different than on the countryside. So main criteria are the following, as you can see. The climate criteria, for example, the heat tolerance, the drought tolerance, the cold hardiness, and also the tolerance to late frosts. There is the plant resistance, so the vulnerability to pests and diseases, and also the potential to host for fire blight, which is a tree disease, and also biological criteria. And other criteria are, for example, the diversification of species, like, for example, to use, of course, still native species, and as well species that by 2070, for example, would be adapted, or that are adapted to a climate that would look like the climate of the Balkans. And then it's also important that the trees, they are selected according to the origin, that they are locally grown in the area where they will be planted, and that they will be propagated in a way that ensures also a high genetic diversity. To conclude, well, in Switzerland, this is a currently rapidly growing market, and in the context of climate change, it is essential to strengthen the role of vegetation in our cities. This requires a strong political will, and from the cities and from city officials and municipalities and different departments to work together. We can like this is important as well in Switzerland, but as well as in Poland, I guess. So multidisciplinary teams are important to realize these objectives, and also substantial human, financial, and logistical resources are required, and to ensure the support and the engagement also of citizens. And as I said, in Switzerland, this is today a currently rapidly growing market for consultancies such as Urbanplan that I work for, and which is part of our work, of our everyday work. So yeah, thank you very much for your attention, and if you have any questions, please feel free. Thank you.
Aleksander, bardzo dziękujemy za
Thank you very much, Alexander, for this presentation that shows a very important element in these Swiss examples. That is that trees, greenery, green infrastructure is no longer limited to its aesthetic function, but is an important element providing climatic resilience. We have two questions in the chat. The first one, what are the good Swiss examples of strengthening the quality of soils while growing trees in the vicinity of streets? It is a challenge for sure. Is there any particular way you do it? Do you use any containers or structures? And the second question, how was the problem of safety solved? The problem of safety of drivers and pedestrians? For example, the threat related to breaking branches during storms or strong winds. So the matter related with the growth of trees and development of this green infrastructure in communication routes or those in the direct vicinity. So could you please answer briefly?
Am I talking to me?
Alexander, can you hear us?
I'm sorry, I actually did not hear the English translation.
Okay. Let's check. Czy już słyszymy się?
Can you hear us now?
Do you hear me?
I can hear you, yes.
Yes, we have two questions.
Yes.
One question from
Mamy dwa pytania.
Mrs. Patricia about what kind of examples for improving soil's quality before planting trees in place where there are sidewalks or street before, and do you use plastic structures? You know, because there is some limitation of soil for trees. When we have more trees, it's probably connected with the soil. Can you give a short answer? And after that, I will ask a second question.
Okay, so to plant trees in the cities, of course, we all have the same problems with underground infrastructure. So the way we would do to orient roots, for example, and to improve the fertility of the soil is before we plant trees, we would make an assessment of the soil fertility and to see if soil needs to be improved. So this is what we first do, and working with us soil specialists. And on the other hand, to allow trees grow, for example, on sidewalks or where underground infrastructure are very present, we have different structure or different options. For example, we would use technical tree planting PIDs. For example, yes, of course, you can use a concrete structure in the 81st centimeters of the soil. So this is where all the cables are, and so just to make sure that the roots, they would grow to both sides, but underneath all those cables. But this is very this is very costly actually to realize. So what we do is that when we plant new trees, which involves, for example, to renovate a whole sidewalk, is that we would just dismantle the whole sidewalk. We would replace the ground that is in place underneath the concrete or whatever is the surface, and we would replace it by a structural soil that is composed of 60% of stone material and 40% of organic material like soil. And trees, they grow very well in those structural soils. And the advantage is that you can put any kinds of concrete or whatever asphalt on top of that. So the trees, they can grow, and it really helps the trees to have more oxygen in the soil. So because in Lausanne, for example, we would not plant trees anymore into a normal kind of soil that is only composed of 100% of organic material because of the lack of oxygen. So we would, if we can, except for parks, of course, where is natural soil available, but wherever is no natural soil, we would plant into those kinds of structural substrates composed of 60% of stones and 40% of with all kinds of underneath infrastructure, and it is less costly than any kinds of concrete or plastic containers, for example, to orient the roots.
Bardzo dziękujemy za to wyjaśnienie i pokazanie, że tak
Thank you so much for this explanation. I'm happy to hear that there is a dedicated solution. Thank you.
Already the translation, so short thank you for explanation how you design in fact proper solution, because there is some kind of challenge with the providing, for example, air, as you mentioned. And can I ask you short second question from Ms. Izabela Karczyńska, how you resolve problem of security for drivers and pedestrians, because more trees give some challenges, for example, during some kind of storm or heavy rain. For example, branches can break and fall. So do you manage in any way such kind of probability of such kind of risk, especially with we know that climate change, from the other side we have heavy rains or heavy snows, and it could make damage, because if we have some kind of outcome for 30% of trees coverage, for sure it will appear.
Yes, of course. So I think first what is very important is that trees in urban areas are being followed by the city services. So that means that you would not just let a tree grow the way it wants. You have to cut branches that would, for example, disturb traffic, higher lorries or whatever, so that there's no interruption of the traffic due to branches that are hanging low. And the city of Lausanne is therefore following all the trees regularly, so just to cut branches. And they are also gradually replacing trees that that are known for being sensitive to storms, or that are, for example, invasive plant species, and they would replace them by more well, resilient and stronger plant species. For example, there is a list, and the city of Lausanne has established this list of plant species, of tree species that are suited to be planted close to the streets and on sidewalks. And for example, you would not find a number of trees that would be planted there 10 years ago. So today we would plant other kinds of trees where we know that they can cope with the urban environment. Of course, I don't know if you have seen or if you've heard about that. In 2023, there was a huge storm in a city which is called La Chaux-de-Fonds. And it has destroyed many city parks, and I would say almost 60% of the tree cover of the city. And but of course, some trees have survived, and today we know that some of the tree species that have survived, they are stronger tree species than some native plants that you would, for example, grow in forests. So you cannot plant the same trees, and this is also what the city is doing today, is by controlling the pollution of the trees, and also by replacing trees that would not be suited for a sidewalk, for example.
Alexander, thank you for explanation. You managing and take care and learn the lessons from the past. Thank you. And szanowni państwo, teraz przechodzimy.
Ladies and gentlemen, now let's, after this very practical presentation of this green infrastructure approach as an area of strengthening resilience, where we have both strategic greening plans and expansion of the coverage of tree crowns, creating green corridors, integrated spaces, both in public and private urban area, to ensure its continuity. But these dimensions themselves, especially for middle-sized cities, do not address the problems that are posed by climate changes with regard to heat waves. And we have with us Ms. Johanna von Toggenburg, who specializes in climate adaptation, heat stress, city climatic resilience, how to strengthen it. Ms. Johanna is working at the crossing point of creating institutional potential, technical solutions. This is something that is very interesting for us, and we're very much interested in this heat toolbox, and that shows the adaptation to climate change and her experience in supporting public administration, especially in this practical translation of heatwave-related dangers to what is particularly important for us, for mid-sized cities, well, with a certain, plainly speaking, budget limitations and all its consequences. She has experience in propagating this particular tool that we will learn about very soon in her presentation, because it's a very important tool that Lucerne, the city of Lucerne, has included in its program for climate resistance, and also by the Swiss Federal Office for Environment. Ms. Johanna, the floor is yours. Tell us about this practical use of heat toolbox.
Dziękuję bardzo. Thank you so much. So just a quick specification. It's not actually the city of Lucerne. It's 4 small communities, municipalities that are part of the Lucerne agglomeration. So just to make that clear, that I'm not speaking on behalf or about the city of Lucerne itself. So I just need to be able to share my screen. Okay, fantastic. All right. So yes, hi, thank you so much. I'm Johanna. I'm the CEO of SICON. SICON is an environmental consultancy, and we basically develop solutions in the field of sustainable development, as well as decision-making processes. We support very often municipalities, cantons, areas in Switzerland with the processes of decision-making, and basically building partnerships between the public administrations, private actors, civil society, etc. And I'm very, very honored to be able to present the Heat Toolbox to you, which is a practical guide for climate adaptation in hopefully also your municipality. Just to give you a general setting of the situation that especially urban areas are facing at the moment. We obviously know that temperatures are going up, especially in the summer and in urban areas with construction density. We notice a very strong increase in heat, and not just that it's increasing the heat during the day through, for example, asphalt, concrete, and so on, but these materials also store the heat. And so not only does it get extremely hot during the day, but also the capacity of the urban areas to cool down at night is very much reduced. And so, as Alexander was saying in his presentation, the fact that we have these materials in cities, that we lack trees and green spaces, that there is a less capacity of infiltration of water, like Tomasz was saying in his presentation, leads to situations where we can have 6, 7, 8, up to 10 degrees higher temperatures in cities than in the countryside. And you can see this here. This is very nicely graphically shown relief of the temperature of the surrounding of the city of Zurich, actually. And you can see how much higher the temperature is in the very dense urban areas, and where some let's say natural areas, for example, the Naturschutzgebiet Kloten-Ried, contribute to reducing that temperature. So just as a general setting. Oops, sorry, I went to the last slide. Let me get back to the beginning. Okay. Okay. And 2024, I was pregnant, so I can very, very firsthand share this experience of the urgency and the importance. And really, we've had, I live in Basel, which is compared to some other Swiss cities, also quite a warm city with a lot of sunshine. And the heat waves here in the last years were really, really tough. First 1 year in pregnancy, I couldn't really go out during hot days, but then I couldn't really stay in because, our buildings are not prepared for this kind of heat either. So it was really suffering. And then the year after, I have a newborn, and what to do with a newborn on a hot day. These small bodies are not able to cope with such heat. So putting cold water compresses and so on, it's really a challenge. So is it for elderly, for senior persons, for people with health issues. So it really affects not only the health, it affects mortality. Actually increased in the summers where we've suffered from heat waves here, and it causes disruptions for schools, for work, for mobility, and it's very, very heavy for vulnerable groups. So it's important for municipalities, cities, agglomerations to take action, and to take action fast. Now, the starting point of our work on this issue was actually a pilot program supported by the Federal Office for the Environment in Switzerland. It was a pilot program on adaptation for climate change. And it's actually a program that supported 50 or more pilot studies and projects. And ours was looking at basically trying to see how can we develop a practical participatory guide for municipalities to identify heat hotspots and implement climate adaptation measures. And we did speak with the city of Lucerne at the time, and they were already, developing a quite a complex climate assessment, climate modeling. And they were saying, look, we're in the process of that. It's not a good time. So we, in discussion with the Federal Office of the Environment and the city of Lucerne, we shifted the focus to these smaller communities who were saying, it's great that the city of Lucerne has a climate model and is going to do a whole climate plan based on this. But as small municipalities in the surrounding areas, we don't have the finances to pay for a climate model of our community and to engage in such a complex big process, nor do we have the human resources to accompany that. And we need a little bit of a, let's say, a more practical, faster, applicable solution. The result of that project is 2 publications. One is a guide on the methodology, and the second one is a tool book or a list of measures that I will explain a little bit. I'll give some examples of these measures later. And you have the QR code here. It's unfortunately only in German, the publication, but nowadays there are several tools you can use for translation. Hopefully that would be useful for you. So just to show you where the pilot area is, this is where the Lucerne agglomeration is located in Switzerland, so quite central and next to a big lake and surrounded by mountains, which has an effect also on some of the hotspot or climatic situations in the city. And these 4, if you like, communities in the agglomeration that we looked at, so Lucerne would be kind of in the center of that faded picture around the lake, and then these 4 communities were surrounding it, and we looked at in Ebikon on the top right, we looked at the main kind of street going through the city, which is obviously, transport, asphalt, no trees, etc. We looked at Seetalplatz in Emmen, which is an empty area that is part of a large development in the past years. Of the whole kind of administration and offices and shopping, so converting it into a shopping area. And then we looked at Sternmattenhof in Kriens, which is an industrial area. And finally, we looked at areas with schools in Haag. And together with these communities, we worked together with these communities. So these communities did not commit to implementing the actual measures, but they committed their time to assisting in that process, so that we could test the process of developing this tool and of the participatory nature, if you like. So the heat toolbox is basically the practical, simple outcome of that project, and it provides a cost-effective tool for ideally for small, medium-sized municipalities. It is a qualitative tool, so we're not going here like in climate models into very quantitative data assessments, but we said look, there is a lot of knowledge that the municipalities already hold, and there is a need to act fast, especially in areas where this heat stress is causing a problem for the people living in the city. And so basically it's a rapid analysis tool of hotspots in populated areas. The qualitative method allows to embrace and bring in all that knowledge that the staff of the municipality and other people focusing on the municipality have. But it's a simple process to develop a solution and directly an implementation plan. And of course, there is assistance for the implementation available if the municipality feels that they cannot do this process or follow this process by themselves. So the toolbox mainly looks at basically the what is the interaction between two main things. So not just the climate aspect, but combining it with the vulnerability of the social aspect. So where do we have sensitive population groups and high population density areas, which are, you know, the highest risk for health? And where does that combine with areas of heat stress, for example, high degree of sealed surfaces, high building density, lack of cooling spaces, and anthropogenic heat emissions. And those two, where they overlap, we define that as a hotspot. The approach basically and methodology can be broken down into 4 steps. We would start out with an assessment of the situation, then go into analyzing the hotspots, prioritizing the hotspots, and then selecting the suitable implementation measures. And of course, each step has its implications. So assessing the situation, while we're not doing a climate modeling, we do want to use existing data, existing models, and basically all kind of urban climate information that is relevant to planning. So we look at that information and we use it to then identify these vulnerable and exposure hotspots. We discuss that together with the municipality to confirm that this is actually correct. And then we go towards prioritizing these hotspots, because of course, you know, you might suggest some measures, but you have to check if these measures are suitable for the context, for the situation, so that they're not unrealistic. We want to suggest something that is actually also realistic for the municipality to adopt. And then we go to looking at this catalog of measures that I told you about, which has different measures for different problems. And there's a decision tree as a support tool to be able to choose, okay, which measure could be helpful here. And then again, discussing it with the involved parties, interested parties from the municipality and the population. And of course, there is different questions that we go through. Are the maps available? Are which areas are affected? Are the measures realistic? Are they suitable? Just to give you an idea of this, is definitely possible within 6 months, and after 6 months you can move towards implementation. You can probably do it even faster, but there's always delays, especially when you're trying to call for meetings to do things in a participatory manner, which is important because it ensures that both the urban planners and the municipality staff and the maybe a neighboring municipality that is affected, as well as the population, that everyone is on board with what is going forward and not later on blocking the implementation. A quick overview to help you understand how do we look at maps. So there's a selection of maps I will in a second that can be used. I think Tomasz in his presentation already showed also some of the maps relevant to the water, so but also to the heat. So the same maps are available in Switzerland, luckily for the whole territory. It's a very rich resource that we can base on. And so we look at maps and we, for example, we identify, okay, what are, you know, where is commercial industrial areas? Where are large buildings? Where is lots of transport infrastructure, car parks? Okay, we will know these are very likely sealed surfaces. We know that it has an effect on nocturnal heat radiation, on lack of cooling, high building density, wind barriers. Okay, we know this is affecting poor ventilation. Lack of, we can see on these maps, of course, where are parks, where are green areas, but also where is a lack of these areas. And so we know that this will have a limited cooling or recovery opportunity, etc. This is for the heat exposure. And we do the same then looking at maps from a more social perspective, the vulnerability perspective. Where are retirement homes, playgrounds, schools and daycare centers, clinics? Here is a high, let's say, grouping of vulnerable populations, and we need to make sure that there is a possibility for these people to get there without additional heat stress, to have a resting ability on the way there, etc., etc. But also places with high population density in general, shopping centers, town squares, public transport stops, and so on have to be included. And here's an example of how we went through this qualitative mapping. So you take a base layer map, and then we started looking and identifying the sensitive population areas, the population density, and then more the heat aspect. So the sealed surfaces, the building density, the air. Here an example of a cold dynamics map in Kriens, for example. Since it's favorably located in terms of cold air formation, it has forested areas north and south of it. It has some mountains that are, you know, creating some kind of cold air corridors. And even without having, if you don't have the finances for a climate modeling, this is a qualitative map. This is reading the city structure, reading the geography of the place to understand roughly what is the potential for cold air to flow into a city, where is it going to be blocked, etc. So just to support the argument that even if you don't have the extensive finances, the time to do a very extensive modeling, it is possible to identify at least these most important areas, these dangerous areas, and to take action quickly. And then layering all these maps together, you basically identify these areas where you need to start taking action. This is mapping here the main traffic routes, the building density, the sealed surfaces, and then the vulnerable populations, and that kind of gives you an idea of areas that you should start focusing on and the very clear hotspot. And yes, here are some examples of the different measures that are presented in the measures book that you could take. And I'm not going to repeat some of the aspects, but You know, for example, green facades is a measure that is very useful. It uses ground or wall mounted systems, sometimes with irrigation. Plants provide shade, the air layer insulates, it allows some cooling, indoor temperatures drop, so at least in hot summers you can stay indoors and it's a little bit cooler without having to put an AC system. But of course there are issues because there is lack of space even for that. Even sometimes green facades, they don't need lots of space, but still. There are, it can impact interior spaces in terms of maybe light, etc. There are some challenges. You need to check the structural conditions, maintenance and irrigation is required. With private buildings, it's not always possible to influence these and so on. And then we looked at synergies, however, to be able to say, okay, if you do this measure, then it also has benefits for many other things. Yes, I see I'm getting close to the end of my time. Let me just show very briefly the last slides. There is creation of pocket parks, which I think Alexander has explained broadly. There is heat optimized surfaces, increasing the albedo. So thinking about which materials are used in building to basically reduce this heat accumulation. But also doesn't always have to be done through greenery. If it's not possible to do it through greenery, then thinking about some other shading options, pergolas, pavilions, sun sails is also helpful if it's not possible otherwise. Why I mentioned the albedo is because Nina actually made me aware of a very interesting recent publication, which is a building materials catalog. So I briefly mapped out here which similar measures they are covering. And last but not least, some implementation examples, because of course you will be asking, okay, so what happened? It's not easier with the different municipalities that we worked with. Sometimes we weren't right in the timing when it comes to city planning. So some plans were already committed and changes couldn't be easily implemented. With others, there are political priorities sometimes. In the Seetalplatz in Emmen, where a big development was planned, they prioritized energy efficiency, which is, you know, also great, but unfortunately not really helping the heat stress situation so much. But we do have some good examples, especially when it comes to schools. They are very aware of the needs of their children, and so here in Hof, one of the schools that we worked with, we're actually planning a new building because of increased number of pupils. That this building has actually won an Eco Prize, both for the building materials, a very high usage of wood, but also the integration of green spaces around, etc. And here is another project where we worked with schools and students themselves, thinking and suggesting measures of planting trees, de-sealing surfaces, etc. on their school grounds as both you know, heat reduction measures, but also educational measures at the same time. So thank you so much. And yeah, I'm available for any questions.
Johanna, bardzo dziękujemy za w telegraficznym skrócie przekazanie
Thank you
doświadczeń.
so much for this brief sharing of your experiences. You mentioned in 2019, 2022, you started a project that helped many smaller towns, a very practical guide that can be used in their situation, but also, I'm sure, a bit larger cities can also find it useful. Thank you so much. Right now, I'd like to ask all our participants to have a look at the chat where we posted our evaluation poll. Please dedicate a minute to gather your opinions. We're still learning. And expressing my gratitude to Ms. Johanna, I'd like to mention that her presentation that will be posted on our website will be also translated in Polish. There was a lot of content here. That's why here we used only the English version, but I'm sure that was very valuable. Thank you very much for your presence. We didn't have questions in the chat, so we can move to another point. I'd like to ask Ms. Lucyna Maury, expert of the Association of the Polish Cities, architect for whom spatial planning has always had a very strong social dimension. To sum up our seminar. Welcome everyone. I'll do my best to be brief and to mention all the presentations that we had the pleasure to listen to. First, we listened to a very content-intensive, interesting presentation by Mr. Stanisław Drzewiecki, chairman of the Municipal Water Supply and Sewage Systems in Bydgoszcz. Very unusual speech that helped us to understand how a vision transforms into an implementation of a program. We're all in favor of sponge cities. That's why we find it particularly interesting, and we approve of this direction of action, but from the whole way, from vision to tangible results and indicators, there is a long way. So we could see today how such a strategy is implemented step by step. What was most interesting for us, I believe, was that this plan was implemented in the course of 25 years. It was a strategy that was very in a very disciplined manner introduced over time, starting with the inventory of the entire network system, rainwater sewerage infrastructure. And it turned out that it's in many ways below the standard. It needs to be renovated, cleaned, etc. So the analysis of technical state is very important. Then there was a decision at the city council level about the payments, the fees for water management. It's an important element. And finally, what impressed me greatly were the models, rainwater precipitation models, in collaboration with academic circles, were all impacted, I believe, by this digital precipitation model. We could see how the city analyzed the utility of land for water retention in collaboration with the State Geological Institute. A very interesting map of water runoff, where we could see on one map these larger precipitations are prognosed, elaborated, and how it affects the entire city area. It was also highlighted that such projects are very demanding because they refer to the entire scale of the city. The whole water drainage system is a system of connected vessels where the entire city area has to be included. And parallelly to this very complex infrastructural project, there was another one could say, that is related with smart drainage system. This system was created with the use of AI, which uses data from many different sources, whether it's maps or the city drainage program. And this is a parallel work that was necessary to implement this huge challenge. 147 investments. This is, I think, impacting for all of us. And throughout these 25 years, 10 times inundations less in the whole area of the city, which is huge. Of course, we cannot neglect the fact, the questions related with financing the program, where to find the financial resources, just as Mr. President said, the funds for the creation and the maintenance of the system are particularly necessary because it was a lack of necessary maintenance or insufficient maintenance that brought about these costs in the first place. The cost and benefit analysis was crucial, and the city could see clearly how much money it would spend on the damage done by the inundations, by flooding, whereas the money invested was much, much lower. And finally, in Bydgoszcz, we also heard about the great educational program undertaken by the Museum of Water Supply and Sewer System, programs at schools, small retention installations in the school areas of the city. The city also participates in city water circles programs, and Bydgoszcz is very eager to share their knowledge. Their publication can be received if you contact the city, the Bydgoszcz Standards of Rainwater Management. But also the guidelines for good practices can be downloaded from the Municipal Water Supply and Sewer Systems website. So very interesting walk from St. Gallen, very interesting, presented by Mr. Tomasz Piątek. What was most important there? We learned simple methods that can be introduced almost overnight, immediately, even if we don't have significant donations or resources dedicated to climate resilience adaptation. But there are things that can be done. For example, green areas of flat roofs, underground and on-ground basins, planting trees. Mr. Tomasz strengthened, emphasized that rainwater is not a residue, is not waste. He also highlighted that in the Merli company and other Swiss experiences, it shows that the idea of a sponge city is very simple. It can be easily visualized and is very positively perceived by the residents. What is the challenge, however, is to coordinate all the activities related with the implementation of the whole idea. It's very interdisciplinary and involves the engagement of many different entities in the city. What also caught our attention in St. Gallen, it's a very good example that the city is not only public spaces that we have to take care of its quality, but also private areas. Hence, the program was created in which private area owners could receive funding for micro activities aimed at helping with the implementation of the sponge city idea. In St. Gallen, care is taken of introducing these rules in local fairs, events where publications are available, how residents can benefit from these solutions. What was also important, interesting about the city, Mr. Tomasz told us how important spatial planning is, highlighting the role of all the planning tools. What was also interesting was the association of architects and landscape architects who undertake to create exemplary draft projects that can be used by the residents. The third presentation by Mr. Aleksander Zautow, landscape architect from Lausanne, who has experience in introducing solutions based entirely on nature in Switzerland, Canada, and South Africa. Also very interesting, the most important sentence I heard is that nature is also a kind of infrastructure. Wherever we're planning new districts, new parts of the city, it is very important to adopt a biostrategy where all these green elements, trees in particular, are as important as the new standard infrastructure, and where the city has already been designed and faces problems related, for example, with overheating or flooding, it is recommended to implement the rules, helping us to come back to the origins. The quote from United Nations comparing trees to the heart, liver of the cities was very important also. What was as limiting CO2 emissions in our cities. And some suggestions that we received, how cities can be cooled down, since so many heat centers, hotspots appear, and the conditions of living are deteriorating because of that. We learned how important trees are. The greater the area covered by the crowns, the more benefits. What was also highlighted was this therapeutic effect of the trees in nature, and also bringing back these natural strata of greenery, the whole lasagna of layers that we want to achieve, recreate in our cities, so that the ground is as close as possible to natural conditions. We also learned a number of techniques to create inventory of greenery in the cities, tree coverage. We saw examples from Geneva and Lausanne, and heard about the LIDAR technology, which is done by analyzing the green surfaces, tree crown surfaces, using a drone or a plane. It was also spoken about tree stress, species that should not be used in cities, because the conditions, for example, heat might be too hard for them to survive. And what was also highlighted, emphasized, was the great importance of political willingness to introduce such changes. The last great example of Lüneburg focused on the heat toolbox. That is a guide on tools that can be used against usually cheap solutions that bring about tangible results with regard to mitigating hotspots and urban heating. We know that larger cities can have access to larger funds, budgets. They have the necessary staff that is available to coordinate large-scale investments, but smaller municipalities do not have either. Therefore, what was proposed to them was a pilot solution for 4 municipalities from the vicinity of Lucerne that suggested hottest places that have to be taken care of as a priority. And this toolbox method lies in adding subsequent layers of analysis. So first, it is infrastructural data that is analyzed, objective general data showing the density of housing, different kinds of ground cover, pavements, natural air access channels in different districts. And then another map is added, analyzing social, who might suffer, especially during heat waves. And only after all these factors, all these layers are introduced on the map, the final hotspot list was identified. So the priority areas that need to be taken care of in the first place, where urgent interventions should be undertaken, and how to counteract hotspots in the city. Very interesting 4 views on the problem. I think it was a great experience for all of us. I'm very grateful for all of you who stayed with us until the end. Thank you very much for this summary, for this overview of what we have learned in these last 3 hours almost. And now I'd like to thank you all and introduce you to another local development forum on the 12th of March at 10. We're going to speak about different topics, speaking of healthy cities, how to introduce all the residents in this program. And right now, on behalf of the organizers, I'd like to thank our Swiss partners, Enco Urbaplan, that helped us to provide the materials for the seminar, all the panelists. I'd like to thank the translators, also sign language interpreters, our technical support, that helped us to see and hear each other without any problems. Thank you all for your attention and see you next time.